I'm Darrell Wallace, Manufacturing Technical Fellow at BlueForge Alliance, and I'm joined today by Ariyan Kabir, co-founder and CEO of GrayMatter Robotics. Ariyan, thank you for being here.
Thanks for having me, Darrell.
So could you talk a little bit about what is GrayMatter?
GrayMatter Robotics is an AI robotics company. At the core, we develop physics-informed AI technologies, and we combine that with industrial robot sensors and tools. And then we create a turnkey solution that we offer to manufacturers as a service. Our current focus is on high-mix, high-variability manufacturing production where you have part-to-part variation, material distribution changes, or you can have large number of SKUs. Traditional automation becomes very difficult for such manufacturing environment. As a result, high-mix manufacturing is still dependent on manual labor. We help manufacturers to augment their workforce with autonomous robots for such environment.
So, certainly I know automation, but you use the word autonomous. What makes autonomous different from automated?
Everything that is autonomous are automated. However, everything that's automated are not autonomous. When we say autonomous, when we say an autonomous robot, we mean a robot that's capable of making its decision from a very high-level instruction. It can program itself from very high-level instruction. Just to give you an example, we offer autonomous sanding, grinding, blasting, coating cells to manufacturers. In our cells, we design the system like an appliance, as simple as a microwave oven. In a microwave oven, you put your food, you press a couple of buttons on your screen, you go back, do something, come back, your food is ready. We take a similar approach. Anyone without the knowledge of robotics, automation, manufacturing details, or engineering or programming can use our autonomous robotic cells. They can roll in a part, press one or two buttons on the screen, go back, focus on some high-level task, and they can come back and their part is ready. Our solutions, the way it works is that you can bring in a part, the robot will scan the part. From the live scan data, it figures out the geometry of the object, it programs itself on the fly autonomously, and then executes the operation. During operation, it takes on sensor feedback from the live contact or other sensor data, and adapts and adjusts its movements to make sure that it can produce consistent quality and prevent any mistakes from happening.
So the systems that you're making, are these your robots? Do you make the robots, or what part is the GrayMatter piece?
Great question. So at the core, the physics-informed AI technology that we develop, you can call it embodied AI, you can call it physical AI. That's the GMR AI that we call, that's our proprietary technology. At the core, we develop that AI technology. And our technology is agnostic to the hardware or the robot. We can work with different robot OEM, different industrial robot arm, and we combine other sensors and tools depending on the specific application. Currently, we heavily focus on surface finishing, surface treatment applications such as sanding, grinding, painting, coating, blasting, deburring, trimming. We do a lot of inspection as well. So depending on the application, we create a turnkey robotic cell with the right robot arm, the right rail or mobile base with the right sensors and tools. And at the core, our GMR AI that's governing all these systems and making the system autonomous.
Okay, so you're integrating commercial off-the-shelf hardware with your proprietary software to make it all work together autonomously.
That is correct.
Okay. And so does this work with, you had mentioned that this works with high mix, low volume. How low volume? How few pieces can I do this with?
Yeah, we are agnostic to volume. It can be high mix, low volume, it can be high mix, high volume, it can be a one-off part that's one of its kind that the robot has never seen before. And in our system, we have certain technology that does not even need a CAD model. You can throw in a part, press a couple of buttons on the screen, and the robot programs itself.
Yeah, that's pretty exciting. And I think you mentioned sanding and polishing. What other manufacturing processes are you either able to support currently, or are you envisioning being able to support?
Great question. So at the core, we focus on, think about applications where you need a tool. You need a tool, it's a tool in hand operation, you make some value-added change to a surface or to an object with that tool. These are applications like sanding, grinding, buffing, coating, painting, spraying, blasting. So these are the 6 solutions we offer today are sanding, polishing, buffing, grinding, blasting, and coating. And when I say coating, I mean different spraying and different painting applications as well. In the future, we are bringing up other tool in hand operations such as trimming, deburring. We are also looking into different addition applications such as welding or additive manufacturing. We're looking at layup applications in the future as well. And for all of these applications, we heavily focus on inspection, NDT, or other QC operations as well.
You and I have talked before about this, and one of the things that has always struck me is you have taken, you've developed a subscription model for your equipment. This is a lot of cost, a lot of complexity. Could you talk a little bit about that subscription model and how that differs maybe from other approaches to capital equipment?
So when it comes to traditional automation, it's always CapEx. You are spending about 90% of the budget even before before you have the solution on your floor and know that it actually works and delivers value to you. So when we started GrayMatter Robotics about 5 years ago, when we spoke with a lot of different manufacturers, we realized there's an inherent fear towards automation because of the very large CapEx and whether it's going to be working for that specific environment or not. We wanted to reduce that barrier. We wanted to lower the barrier to entry for a lot of different manufacturers. It can be small, medium-sized manufacturer, or it can be a Fortune 100 company. We took a subscription model where the manufacturer doesn't have any risk upfront. They don't have to make any upfront capital investment. They can sign up an agreement for a multi-year subscription, and we deliver the full turnkey solution. We work with them throughout the process. From signature to delivery can be anywhere between 2 months to 6 months, depending on the application. And once it's up and running, delivering real parts in production environment, then the subscription kicks in. And within the subscription, more importantly, not just lowering the barrier to entry, but more importantly, the solution, the technology is evolving, and the manufacturers can benefit from that. They are getting quarterly updates on not just software, but also they can get annual updates and upgrades on hardware technologies such as tools and sensors. As you know, the robot, rail, those technologies are not evolving as fast. However, the sensing technology, the tooling technology, the AI technology, the software technology, these are evolving much rapidly today, the compute technology. And the benefit of the subscription model is that the manufacturers can stay up to date. They're never stuck with what they got on day one. Every month, every quarter, every year, the system is evolving, giving them more value, either lower cycle time, significantly higher uptime, significantly more reachability within the part, you name it. The other big benefit of the subscription model is that the manufacturers, they don't have to worry about maintaining the system, taking care of the system. At GrayMatter Robotics, we take a partnership model with our manufacturing partners. We take care of end-to-end. If something goes wrong with a sensor, we're going to replace that. If something goes wrong even with a robot, we're going to come in and replace that. We have 24/7 remote support. We have on-demand, on-site support. I'm very happy to share that across our fleet of robots deployed all over North America, we have 95 to 99% uptime, and 97% of issues we can resolve under 5 minutes remotely.
That's very interesting and very different than I think a lot of folks have chosen as a business model. I'm going to ask you to be a little bit introspective here and maybe share what is the state of autonomy. I mean, this notion it's wonderful, it's
Right.
exciting, but the reality is not as maybe effective as what certainly I hope it would be. Where are we today? Where are you today? And where is the industry more broadly? Some of your competitors. What are some of the different philosophies about it? Just kind of give us some context.
I think Darrell, to be completely transparent, we are still far away from general artificial intelligence. We're still very far away from having a solution, one size fits all, right? What we're seeing in the industry today, what's available today, and that's helping manufacturers today, are application-specific solutions, application-specific AI that can help augment the workforce, augment the existing labor force, and amplify their productivity. So we are seeing not just GrayMatter, there are a few other companies focusing on different application domain, let it be logistics, let it be manufacturing, let it be agriculture, where you're having application-specific autonomous solutions that can augment the workforce and help manufacturers or farmers or logistics and warehouse operators bridge the gap between their demand and capacity. And overall, what we're seeing in the industry today, Darrell, is that if we don't solve the labor shortage problem, by 2030, US manufacturing will be at a risk of $1 trillion every single year. There are millions of open jobs in manufacturing today, and that available labor force today is reducing every single year. So we see these autonomous solutions and application-specific solution today to augment the workforce. And as these technologies are evolving year over year, we see that ability to bridge the workforce even more.
Okay, so we have autonomous solutions as a potential technological approach to the workforce shortage. We have currently some capabilities in application-specific uses of autonomous. What are the barriers? What are the big challenges you see that would allow us to broaden the adoption of autonomous?
I would say one of the key barriers to broaden the adoption is awareness. I believe, when we speak to manufacturers, often we are their first foray into robotics or automation even, right? A lot of high mix, high variability manufacturers do not know that this technology exists today. They do not believe that this is possible. They do not believe high mix can be automated, right? Keep aside the autonomy layer. They do not believe that high mix can be automated. To them, whenever we tell them that the robot programs itself and it can adapt to their needs, to them it looks often like magic, right? So I think awareness is a big piece of it. The second thing I would say is especially in different industries where you have large parts, right? The floor space, the real estate is also a big challenge. All these manufacturers, they have their current way of doing operation, they have their current way of running manufacturing. If you need to introduce robots into the existing workplace, it often requires reshuffling some of their existing workflow, and that can be a daunting task. However, to help that side of the adoption, we are seeing a lot of robotics players, including GrayMatter, offer mobile system that can help manufacturers have a smaller system that can be moved around. They don't have to create a big change in their current workflow. And then finally, I would say the overall understanding of production requirements and bridging the gap with the engineering workforce within all these manufacturers. Often we find the production folks and the engineering team to be disconnected, and we need more connectivity to bring everyone on the same page on the requirements.
How about on the capability side, on the technology side? So we talked a little bit about the adoption, but what is needed to enable autonomous manufacturing to be more capable?
Right. I would say again, I think we need to look into what's available today. Where can we start, right? And if you think about having full end-to-end autonomy in any production floor today that's high mix, that's quite difficult or quite impossible. I think the right way to think about for all the manufacturers would be, how can I create a team of robots, humans, and AI? The team of human, robot, and AI, and where do I start? It's a journey to value, right? Where do I start today where I can see some value and people can be more productive, and over time you can have a lot more to be done by robots as more and more capability come into the picture. Let it be more computation power, let it be better sensing technology, let it be robot-specific tools, right? A lot of hand tools today are made for humans. They're not designed or optimized for robots. So as all this technology evolves, the capability will increase. So what we need is a journey to value mindset and a plan for all these manufacturers so that they can create an optimal team of humans, robots, and AI, and over the time, they get more value out of that team.
So if you could wave a magic wand, what's the one technology that you wish were further ahead than it is today that would be an enabler for you?
I think it's a wish. It may not be in the realm of physics, but when it comes to space constraints, right, we always wish we had more payload, precision, and speed on a smaller footprint robot, which again, may not be in the realm of physics today.
So you talked about the impacts to the workforce shortage. Are there any other broader impacts around, your approach that you're working on and others are working on around autonomous?
Right.
Why does that matter? Why does that matter to us as a nation? Why does that matter to BlueForge and our friends in the submarine industrial base? How does this change things?
I think there are a few things. I think at a high level, I think it's really, if we look at the broader national interest, right, the security interest, I think this is very critical for us to be able to bridge the gap, have our industrial base ready to meet the demand that we have today, right, as the world is evolving, as the political landscapes are shifting, right? So we need to be ready as a nation. I think that's very critical. But the other thing I would say, other benefits of these autonomous solutions or robotic solutions are that you can get consistent quality every single time. You can reduce or eliminate scrap, repair, and rework operation. That takes so much effort, so much time, right? I mean, just within the submarine industrial base, correct me if I'm wrong, I believe there is 5 million man-hour shortage, right? And a lot of the man-hour are not just going into initial production, but also going to repair, rework, scrap, and then a lot of man-hour goes into maintenance and repair operation. So I think the consistency on the quality front is a big benefit of robotic solutions, AI-based solution that can really help manufacturers. And the other benefit that we're seeing is the overall system uptime and overall productivity increase. It's not just a productivity increase because robots are faster, but because with advanced AI, we can have now more sophisticated prognostics and health management system for these robotic cells, where you have very high uptime. A lot of these robots are now able to use advanced AI to detect what can go wrong and prevent that from happening, or curate a maintenance schedule that can give you much higher productivity and longevity on your systems.
And are you envisioning that these systems replace workers? Are they augmenting workers, or how does this?
Yeah. We have never seen any manufacturer replacing their workforce with robots. We have always seen they're augmenting their workforce. It's very hard to find and retain your workforce in the first place. No manufacturer today wants to, eliminate their workforce. They want to retain them. And what we're seeing is that a lot of these tasks, such as sanding, grinding, blasting, painting, coating, these are so difficult on your body. No one wants to do these jobs in the first place, rightfully so. And whenever we deploy a system, from our experience, what we have seen, the operators who were doing these jobs by hand before, they embrace the solution as a multiplier to their productivity. And this has happened to us in 4 independent occasions, Darrell. Believe me, the operators, after using the robot for 3 weeks to 4 weeks, they've come back to us and shared they can now go back home, they can play with their kids or their grandkids, their body doesn't hurt anymore. So those are some of the profound impacts that we're seeing from robotics, AI, and autonomy.
What's next for GrayMatter? What can we look forward into the future? Any exciting news to share?
Sure. I think one exciting news I'd love to share is that we are focusing on building some mobile solution. So far, all the solutions we have deployed in production are robot on a rail or robot stationary solutions. However, we are seeing the big need for mobile systems to be able to work around existing workplace. And we are planning to build and launch a mobile system that can be useful for all these applications.
Fantastic. Well, I look forward to seeing that. Ariyan, I want to thank you for the time that you spent with us today and for sharing a little bit about autonomous robotics, and really appreciate it. Thank you so
for
much.
having me.